Hello, sorry I don't speak Vietnamese, but I hope English is okay for everyone. My name is Laurent Corpataux, I'm from Switzerland. Initially I was once a carpenter, and then after carpenter I did engineering. We are specialized engineering in food technology. And then after that I spent a fair amount in Indonesia, and the last 2 years I was working with National University of Singapore, Department of Architecture, and now recently we also opened a company, it's called Pairing Timber Technology, where we try to utilize local resources from Southeast Asia and create more added value within the countries itself. Yeah. I'm in contact with SIPPO here, so thank you very much for having me here, and maybe we can switch to my presentation. Today I'm presenting you about the value chain within the timber value chain in Vietnam. So currently, what we understand is Vietnam is the largest exporter of wood and chips for carbon paper worldwide. If you think about this kind of product, it's very good in terms of fast growing because it's acacia but it's not really good in terms of adding value to the product, because basically you just chip the woods that you have, and that's the product that you export. So the question is, how can we diversify into higher added value products within Vietnam for the local manufacturing sector? With SIPPO, we are focusing on technical wood. So technical wood means we go away from the traditional methods how we use it, and we put more engineering into the product and the product development. So we have currently like 3 different product categories. One is engineered plywood and lial. Then we have bare-core, block-core furniture. And then there is a third category, which is for Vietnam still very new, but in Europe is already quite established, is mass engineered timber. So here we utilize the timber to replace steel and concrete in the buildings. So in this building here we see the steel member, for example, this can be replaced by timber, engineered timber. This is to illustrate you that it's important to focus on all aspects along the value chain. So we want to add value along the whole chain, not only in the forestry, not only in the application, but all the different stakeholders have to gain more value. To give you some examples on engineered LV and plywood, I see we also here in your office, we also have plywood tables. So plywood seems to be also quite established in Vietnam. The thing is now you can even go a step further where you utilize plywood as a low-grade timber, and then you can glue on top of each other. You can glue and have a nice finishing layer to get a more added value product out of it. Another variation is here. This is called like a triplex, where we have different directions of the grain, and by doing so you get also much better stiffness within the product. Just to give you a brief example what it means to do production for plywood, since you have already the manufacturing in Vietnam, this should not be very new to you. So we get the timber from the forest, then we do the peeling, the grading, and then we dry it, and then in the end we glue it together to engineer plywood. Yeah? So this step here is now very crucial for manufacturers, the gluing part and the grading, because if you just peel it and you glue it again together without doing a proper grading, you just get plywood without having a strength class. So later on it's going to be difficult to focus on export markets. But if you do a proper grading of your veneer, and later on of your panels, you get much more added value and less waste. Yeah. Talking about innovative applications of this case here is engineered alveoli or plywood. So if you compare the traditional method how you do the chairs, the armrests, is you would use a solid wood and then you glue it together and then you cut out what you need, right? So it creates a lot of waste. It's not very efficient. But for example, if you utilize, like you see here on the right side, the image for the armrest, if you utilize engineered, in this case is alveoli, laminated veneer lumber, and then during the gluing process, you are able to bend it. So in this case here, you have no wastage, you have much more sustainable products, and it's also much more stable. So the right side is one application how you can add on more value if you think about going from solid woods into engineered timber for the furniture sector. Then here on the left side is also if you would use a solid panel and then you cut in the strips, most likely it would still drag on the other side, but because with the alveoli or the plywood, you have separate layers that are glued together. So if you cut in, and then you have here on the outside, you have still a few layers that are intact, you don't cut into these layers. Then as furniture designers or furniture manufacturers, you can do the proper bending, and on the outside you have a nice curvature and a good finishing. Then on the top, left is just one example, is also if you have engineered timber, you get a higher strength with a similar density. So density means how many kilogram per cubic meter material. So here, if you want to design slim tabletops, for example, then you use solid timber. In order to achieve the same slimness, you would have either to go with a hardwood, but if you use the same timber with the same density, your cross-section will be much bigger. So you use the material much more efficiently if you have the engineered wood for the furniture.
So how about the density?
So the density depends. If you use, for example, acacia, then we talk density-wise around 500 kilogram per cubic meter. Yeah. So if you, for example, can produce plywood, acacia, your density will not increase a lot, so it's around 500-600 per cubic meter. But then in order to get the same strength with solid plywood, solid acacia, probably your cross-section would have to be double of what you have with the engineering. So you also double the weight of your table, right? If you think about mobility and moving around. Another application, this one is also one that is commonly used and produced in Indonesia now. It's called block boards. So in the middle layer they use plantation timber, and for example also the acacia, which is lower in density than the hardwoods, but often wise is a low graded timber, and you cannot expose it to the outside because it's not nice for the clients. So in this case here they use the low density for the middle, and then on the outside they have some things called HPL, high pressure laminate, in order to get a nice finishing. And by doing so, those applications are very important for things that are moving around, that are using fuel, because a train has to be as light as possible, or a trailer has to be as light as possible. So you want to try to put in furniture that is as light as possible, but still gives you the strength and the quality of a high-end furniture. So in this way here you can utilize low added value timber in the inside that people want here, and on the outside you do the added value with HPL, for example, high pressure laminate. Picture side. So another option that is